Okay, this is Geometry 4.6, Similarity and Transformations. So the first thing that you need to know is what similar figures are. Going back and reviewing what congruent figures are, congruent figures have to have the same size and the same shape, or all the corresponding sides and all the corresponding angles are congruent. It's a little bit different with similar figures. Similar figures basically are just the same shape. Okay, that doesn't mean all triangles are similar, but for the same shape, what that also means is all the angles are congruent and then the sides are in proportion, or there's some sort of scale factor. So since we just went over 4.5 dilations produce similar figures. So I can start with a triangle, for example, call it triangle ABC. If I dilate that, let's just say the scale factor is 2, or K is equal to 2. And I come up with triangle DEF, then all the corresponding angles are congruent. Angle A is congruent with angle D, angle B is congruent with angle E, and angle C is congruent with angle F. And the sides are in proportion, or there's a scale factor. So the ratio of side AB to DE, since the scale factor is 2, whatever AB is, like 3, then DE would be 6. If BC is 2, then EF would be 4. If AC is like 2.5, then DF would be 5. So the ratio of AB to DE, that's 1 to 2, would be the same as the ratio of BC to EF. Remember, if you set 2 or more ratios equal to each other, then that's what forms a proportion. So that's what I mean, or that's what the definition means by the sides being proportional. And then lastly, the ratio of AC to DF would be the same. Those are similar figures. And then we have similarity transformations, just like we had congruence transformations. So for congruence transformations, a reflection, a rotation, or a translation, or any combination of those, a composition of transformations of any of those would be congruence transformations. Similarity transformations have to include, if you have a composition of transformations, a dilation, or a dilation itself is a similarity transformation. So your similarity transformation is just a dilation, or it could be a composition of transformations, but that composition of transformations have to include a dilation for it to be a similarity transformation.